and functionalities of the WEkEO platform. Today, we'll bring everything together by completing our overview of the tools available on the platform. By the end of this session, we hope you'll feel confident and well-equipped to start exploring and using WEkEO on your own. Before we begin, let's quickly go over some house rules to make sure you enjoy this webinar to the fullest. Please don't use the chat box on your right-hand side. Use it only for questions. Use it only for small chat or casual exchanges. If you have a technical or content-related question, we invite you to use the dedicated Q&A section that you can find at the top of your screen. Simply click on it to open the dedicated space where you can ask your questions to our speakers. We'll have a single Q&A session for all speakers at the end. So when you submit a question, it would be really helpful if you mention which speaker it's for. And while you're in this section, you'll also see a quick survey about today's webinar and the whole series. So feel free to fill it out anytime during or after the session. During this series, we're also giving you the opportunity to speak directly with our speakers. So just use the raise your hand function at the bottom of your Zoom screen. And during the Q&A, we'll give you the microphone for up to 3 minutes to engage directly with the speakers. Please use this option for relevant questions linked to their presentations and the Copernicus WEkEO service. And don't forget to also write your questions in the Q&A tab so we can keep track of them for the post-event report. When we give you the mic, please make sure that you ask one question because we want to be able to give the mic to as many people as possible. Finally, we encourage you to visit the guidelines and resources section on the event website. You'll find useful links to the materials and tools we've been discussing for the past 2 sessions and today. And now I'll hand over to the second host of today's session, Daria Andrievskaya from Noveltis.
Thank you, Marine. Hello, everyone. My name is Daria, as we presented. I work at Noveltis, and yes, I will be your second moderator for today. And well, I will start with a short presentation of the speakers of today. So, well, today we'll have me and Marine, as you already know, and then we will have our speakers. So first is going to be Anna-Lena Erdmann. She's a Copernicus Data Services engineer from EUMETSAT. Then we also have James Warndell, who is a software developer from ECMWF. And then Michael Lunda from European Environment Agency. He's a software developer as well. And then we'll have our use case presentation by Stefano Bali, who is CEO and founder of SaferPlaces, and he will present, well, the SaferPlaces itself. And well, first presentation is by Anna-Lena, and she will present you such functionalities as xcube and EOCanvas. Anna-Lena, you can start.
Yes, thank you very much for the introduction. Let me share my screen. I hope you can all see it.
Yes, we see it.
Yeah, I have the pleasure to introduce you today to the 2 WEkEO tools, EOCanvas and also the xcube on the WEkEO workspace. To maybe put those 2 tools a bit into perspective, also from what you've heard maybe in the first 2 webinars. So the WEkEO services offer a really broad range of services, like from data discovery, the viewer, Jupyter notebooks, to data access. So really getting your hands on the data through an API or using Python or R, or also tools like the Earthkit, which we'll hear later about, to the data processing. So really to then work with the data and to do some hands-on work with the data. So in this presentation, I will not touch like the data discovery and data access part of the services, but really only focus on the 2 data processing services, EOCanvas and also the data visualization component xcube. Let's start with the EOCanvas. So what is EOCanvas in short? So it's a service that provides serverless processing for all Copernicus data to users. And we serve it to users, so you can use it through a Python module or an API that enables you to process and analyze data without needing to download the files to your local directories. So it's pretty nice if you know how big Earth observation data can be. The EOCanvas is practically a solution to deal with those large files without overloading your computer. So what does that mean? Like when you really work with the data, if you have a hands-on use case you're working on using Earth observation data. So what you might be familiar with, like how I have been like working on EO data for a very long time is like I have my computer, like my workstation, what I'm working on there, I have all my software installed. Then I send an API request to, for example, the WEkEO API to fetch some data. Then the data gets back to me, to my computer where I save it and then where I process it locally. That works okay up to a certain degree, but it has like some disadvantages because like soon you work with terabytes of data, you have to like support the data processing with large computational resources on your local PC, which you might not have, and also you have to manage multiple software installations on your PC, like for example, like whatever like software you're using for your processing, Snap, GDAL, Python, and so on. So EOCanvas tries to solve these three issues, like the large computational resources needed on your PC, the terabytes of data which need to be moved, and the multiple software installations which need to be managed with its offer that you can use the EOCanvas to process WEkEO data without downloading, to implement the commonly used software on the cloud so you don't have to manage them on your PC, and then bringing both together, so processing the data with your software on the cloud. So with the EOCanvas, the Earth observation workflow now looks like this. You send the data request, but also the workflow request to our WEkEO system, to our WEkEO cloud. Then it still fetches the data, but the data, you see here, it stays in the cloud. Then the data is processed within the cloud using the EOCanvas module. And then what you get back is only the results. So a really small condensed file, or maybe even only a table. To show you how this works in action, I've prepared like a small demo in a Jupyter notebook, which I'm going to jump to. Can you see the Jupyter notebook now?
Yes, we can.
Okay, perfect. So this is the WEkEO workspace environment. If you are a user of WEkEO, you have access to like this Jupyter Hub environment where you can also find all the different notebooks. So you can just check out the link in the slides and check it out yourself. You can run the notebooks yourself after this webinar. And this notebook practically shows you a small demo of how you can take like one big satellite tile of the Sentinel-3 satellite and just make a really small subset. So take a huge file and only get a small subset without downloading that large file in the first place. Of course, we first have to do like some imports of the Python modules and the necessary functions, and this is what we're planning to do. So this white footprint is like the one file of Sentinel-3 Olchi, which is usually around like 700-800 megabytes. And what we want to do is we're only interested in that really small part here, like where is marked 2. So we want to use the EOCanvas to get this small subset. The EOCanvas, it also works with the harmonized data access, so the WEkEO HDA. So what you first have to do is you have to define the inputs to the EOCanvas. And in general, the EOCanvas takes 3 different inputs. One is the data you want to process. Second is the workflow you want to execute. So in our case, the data we want to process is like one file of ALTI data of the Sentinel-3 satellite. The workflow we want to do is making a subset. And the third input to the EOCanvas is then the like some configuration parameters, if the file needs to be unzipped and so on. So first, we define the data. This we do with the harmonized data access API request. You can get this, like, for example, when you look into the WEkEO viewer, then there you'll find lots of help on how to define this request. The second thing is the processing workflow. And here comes into place what I mentioned with we've deployed the software on the cloud. So our EOCanvas has a the Snap software implemented. So you can use the Snap and you can use like the maybe processing graphs which you have used before and just apply those in the EOCanvas. We also have different software, like for example, the UMATSAT data tailor, and we are always looking for like user feedback on which software to include next. So if you have any feedback on this, any software you would really like to see deployed on the EOCanvas, just yeah, let me know in the Q&A session or just write me an email. This feedback is highly appreciated. The workflow is defined as an XML. I have already prepared this in the input graph section. So this is how it looks like. You see that you have like the input placeholder. Here you have like a subset of bands. So we don't use all the bands, but only a subset of those. Here is a spatial subset. So all this is already predefined and you can just configure it how you like it. So if you want to use a different area of interest, this is the place to go to and to change the parameters. And third is the configuration parameters. This is like just some configs which are needed by the EOCanvas. Then here we put all of this together. We put the Snap process together, like similarly to the Snap process, we have the data tailor process and so on. And this is then in the end like the thing that is passed on to the API. So that's what the API gets. Then we let the process run. I ran it this morning already so that we don't have to wait now. You see, I started at 55 and it took like around 1.5 minutes. Then we download only the result. And we can quickly check how large the result is, because it's always interesting to compare. And you see the result is only 4 megabytes. So what we did, we avoided downloading 800 megabytes of data, but only downloaded 4 megabytes, which is quite powerful, especially when you don't have so much bandwidth, etc. And then just we read the result, and then we can just use any Python libraries. Here I use xarray to open the data set and to plot it. So this is practically how the EOCanvas works. So what is important is that you remember, okay, you have the selection of a software deployed on the EOCanvas. So right now it's Snap and the UMATSAT data tailor, but open for suggestions. And you always need like these 3 inputs, the data, the workflow, and the config parameters, to then combine those to your process and then run the process. With this being said, I will jump back to the slides. You see that here you have the link to the notebook. This will redirect you to the Jupyter catalog. So from there, you can either open the notebook in GitHub, or you can open it in the WEkEO workspace, like the WEkEO Jupyter Hub, where you can try out the EOCanvas your own. Now I go to the next tool. I go to the xcube viewer. And what is the xcube viewer? It's a plugin for the xcube Python package. It was not developed by UMatsat. I don't take any credit of this. It was developed by Brockman Consult GmbH, but it's an open source package, and it's just really, really nice and really neat. That is why we, as WEkEO partners, we decided to also like make this tool available to users through the WEkEO workspace. Xcube in general provides Earth observation data in an analysis-ready form to users, so this kind of a data cube format. And the goal of the viewer is to take those data sets as data cubes and to publish and visualize the data using maps, using time series charts, etc. And as I said, we just really liked this application. We really liked the xcube viewer, so it's now fully integrated into the WEkEO workspace. Which brings me to my next live demo. This is a notebook. It's also available in the Jupyter catalog, and it kind of combines the both things. I thought, okay, it's a nice showcase of like how the EOCanvas and how the xcube viewer, how they work together, how they can be used together. So I decided to show this example. So I will jump right back to the notebook. So what we do here is we create a data cube from the Sentinel-3 Olchi data. The Sentinel-3 Olchi data, it's Earth observation data, mainly for like the level 2 products, which are provided by UMatsat, are mainly for marine monitoring. So you can, for example, see algae blooms, you can monitor ocean color, and so on. And they are not yet they're projected on instrument grid when they come from the satellite. So it's not so easy to just download the data and like view it in the xcube viewer just now, because you do not have like this association of pixels with like latitude and longitude values that easily. So it is a really nice use case of like using the EOCanvas together with the xcube viewer, because we'll first use the EOCanvas to take several satellite scenes, several image tiles from the Olchi instrument. Then we project them, we subset them, we bring them to a regular grid. We make a data cube out of it, and then we put this data cube into the xcube viewer to visualize the data cube. So that's the plan. Let's see how it looks like in the notebook. As before, we're doing some imports of the necessary packages. You can see here we now use the data tailor process. So instead of Snap, we use the other software deployed on the EOCanvas, the data tailor. And oops. We do a similar thing again. So we have like a large scene, and we are only selecting a small portion of that. Like the subset is slightly larger than in the example before. And yeah, we define the area of interest, we define the start date and the end date. And we again use the HDA to filter for the scenes which we want to look at. And the difference now is that we do not only have one scene, but we have several scenes. So the goal is to use the EOCanvas to not only process one scene at a time, but to scale this up to have like several scenes at the same time. Now we load again the workflow file, also from the input graphs. you remember when we used Snap, it was an XML graph. Now it's a YAML file. It looks a little bit different, but you can just use. This is how it looks like. So it looks like way simpler than the Snap graph, and you can just like when you want to apply this to your own workflow, you can just use those as like a template and just change what you want to change. And yeah, you can also change the YAML file within the code. So this is what we're doing here. We are adding the region of interest to the chain, and you see here, like in the original file, there is no region of interest yet, and here in that file, you see the region of interest was added. So it really it has a lot of flexibility to just adapt it to your own workflow. Now we launch the EOCanvas function. We launch like 3 at a time. And this is what you can see here. So that is also a nice thing about the EOCanvas, is that you can really like parallelize the processes. So we are now like I think one one process here takes around 3 minutes because we have a larger subset and we're doing some reprojection, so it takes a bit of longer time, so 3 minutes for one process. But because we are launching them in parallel, after 3 minutes we have 3 tiles processed, and that can be scaled of up to 10 processes in parallel. And if you need more quota, if you like have a massive project, you reach your limit, your quota limit, you always have the possibility to just write an email either to the user support or to me directly, and then we can see how we can increase your quota. Then we take the results. They are here. You see now we reduced like from 700, 800 megabytes to 15 megabytes, and we create a data queue out of that. We have now really nice latitude, longitude, and time dimension. And now we only start using the xcube viewer. So after we have gone through all this process and now we have a data cube, now we can exploit the xcube viewer to really, visualize the data. And I already started it. I hope it still runs. Yes. So this is what you get in the xcube viewer. So you can interactively look at the data. You can zoom in. You can take a look at areas where you have like lots of chlorophyll. For example, here in this bay area, there is a high amount of chlorophyll seen by the satellite. You can also go through time. So we have the different time steps all here. You can place a point. You can see a time series of this point. Okay, it's now a bit hidden here, but it usually, oops. Exactly. And this works really, really nicely also with longer time series, longer than just three points in time. And yeah, you can also share this link with others. And yeah, it's just a really nice way to work with your data and to visualize your data. It has like, it's fully integrated into this, into this notebook, but you can also open it in a separate browser window. And then you have like a bit larger, a larger view. Okay, then this was all from my side. Thank you very much. I hope you found it useful. Feel free to just take a look at the notebooks yourself afterwards, try them out, change some parameters, and yeah, have fun exploring EOCanvas and Xcube. Thank you.
Thank you, Annalena. That was a great presentation. I hope we'll have some questions for you later at the Q&A session. Now we will move on to the next presentation, and it's going to be a WEkEO Earthkit presentation by James Warndell. James, are you okay?
I'm here. Hi. Good morning.
Great. Hi.
My screen share up. There we go. Hopefully that's all working okay.
Yes, we can see them, but yeah, I guess, yeah, now we see it. Great.
Great. Thank you very much. Good morning, everyone. My name is James Varndell. I'm a software developer from ECMWF, and I'm going to talk to you today a little bit about Earthkit, which is an ecosystem of new open source tools being developed by ECMWF and with the open source community. So I'm going to start with a little bit of history first as to where Earthkit comes from in the context of Copernicus. So some of you who have used the Climate Data Store before may have been familiar with the CDS Toolbox, which used to exist in the legacy CDS. So this was an online Python editor and environment which provided a cloud-hosted access to the whole catalog of Climate Data Store datasets. With no need to download any data yourself, you could process everything online. And it provided a broad suite of tools for processing and visualization, and it would generate interactive web applications at the end. So it's quite a popular tool, something that a lot of users of the CDS enjoyed, but it was quite a bespoke tool at the same time. So some of the good things about this were that you could process everything online, which meant you didn't need to download the large volumes of data on your own machine. The tools we provided were very high level, very straightforward, which made it easier to analyze, visualize your data sets from the CDS. And you could actually develop basic web applications entirely in Python, so you didn't need to know any front-end technologies to make web applications. Sounds good, but there were also some not so good parts of this. This was an online-only tool, which meant it was impossible to actually use the toolbox offline because it was a sort of service-based technology. Even though it looked like a normal Python library, it was actually running services in the back end. It was also a very steep learning curve. So these tools were completely bespoke for the CDS, and these weren't necessarily tools that users were already familiar with. So you had to start learning the tools for the CDS from scratch. And then for as far as compatibility is concerned, these tools only worked directly with datasets in the Climate Data Store. And then there were some slightly more complicated aspects to it as well. So the performance was very dependent on a short-lived cache that we had in the Climate Data Store. Because, as I mentioned, these were service-based functions and tools, it was quite a complex infrastructure, and it often led to quite opaque error messages that were hard for users to debug. And this also made it quite hard to maintain and develop the tools. So if you wanted external collaborators to contribute tools, it was quite hard to get into the understanding the ecosystem and how it all worked because it was so bespoke. So that's just a bit of context from the Copernicus side as to where Earthkit came from. So we realized when we were redesigning a lot of our tools for the new Climate Data Store that what the tools we develop should really do are lower the barrier to entry for interacting with Copernicus data, make common tasks as straightforward and as efficient as possible, crucially be interoperable with data both across the Copernicus space and also beyond, and also really embrace open source. So make it as easy as possible for people to contribute, to explore the code, to understand the code. So based on these criteria, we started a project called Earthkit. So Earthkit is an ecosystem of open source Python tools for earth sciences. So Earthkit streamlines earth science workflows with a very high level API that makes it very simple to get hands-on with all sorts of earth science data. A modern architecture, so it's designed with machine learning and GPU powered up workflows in mind. And also interoperability with the essential Python stack. So Earthkit is built on top of all of the tools that I'm sure many of you know and are very familiar with, things like NumPy, Pandas, X-Ray, and Friends, but just reduces the boilerplate code that you would normally need to write in order to actually get your specific data. It tries to sort of unify data access and analysis through a really simple high-level API. So yeah, so why use Earthkit? So as I say, Earthkit bridges the gap between data sets from different sources, lowers the barrier to entry. And I should mention Earthkit is not a Copernicus specific project. It's a project under which we're modernizing tools used across ECMWF. So that's across Copernicus, it's across Destination Earth, and it's also across ECMWF's core activities. So the idea is that we can use the broad range of things happening at ECMWF to make these tools as powerful as possible and to support as many different use cases as possible, all while embracing open source. So to introduce you to the ecosystem, this is where we are at the moment with some of the different Earthkit modules. So Earthkit is a completely modular software. So each of these is a separate Python module, which you can download on its own or as a whole package together. So we have things like Earthkit Data. Earthkit Data is a format agnostic interface for earth science data with a focus on weather and climate data. So it makes it very, very easy to access a wide range of file formats through a very, very high level interface. So lots of different files like GRIB files, NetCDF, ZAR, GeoTIFF, all the popular typical sort of file formats that you'd be familiar with if you work with earth science data. But there's a single interface that makes it very, very easy to sort of forget about your file format and let Earthkit do all the heavy lifting for you. It lets you read, inspect, and slice data or transform it directly into the Python objects you may be familiar with. So you can go straight from any of those different data source types to NumPy arrays or Pandas data frames or X-ray data sets, for example. Plus, we have APIs for accessing data from files. You can get things from local files on your machine, or directly from URLs or S3 buckets or OpenDAP endpoints, and many more. Plus, we have direct access to Copernicus services like the Climate Data Store, the Atmosphere Data Store, and of course WEkEO, and also direct access to some of ECMWF's services like Mars and Polytope. And I will cover a bit more about how to directly access Copernicus services later on in the presentation. We also have another package called Earthkit Transforms. So this is a processing package which tries to handle complex data processing with a very, very high level API. So this is largely built on top of X-Array. And the idea here, these are very similar to tools that some of you may or may not be familiar with from the CDS toolbox. We had things like doing spatial masks or doing resampling of data you might have, for example, daily data that you want to resample into annual data. So we have some really high level functions that let you do that in a very human readable, very, very straightforward way. So you have a little example of the API there. So loading a GeoJSON file with Earthkit data, and then just applying that to some gridded data, and then very quickly visualizing that. You can see you can very easily, for example, mask data over a shape. We have Earthkit Meteor, which offers efficient and convenient meteorological computations. So this is used operationally by ECMWF in our post-processing workflows in order to produce downstream products for users as part of the core ECMWF offering. So it has a bunch of essential meteorological formulae built in, so things like extreme forecast index, those are things in there. It's reliable and efficient computation that's been optimized specifically for being able to be GPU acceleratable. So Earthkit actually does support in its backend the Python array API standard, which means you can swap out processing pipelines to use things like PyTorch or I think CUDA as well, instead of NumPy to speed things up if you have that sort of infrastructure. So sort of developed with operations in mind as well as the sort of day-to-day user. We have Earthkit Regrid. So this is a package that regrids data across different grid types. So it supports a diverse range of grids, including sort of regular structured grids, and also things like hill-pix, octahedral, complex grids that have traditionally been quite hard to work with in the scientific Python space. So Earthkit Regrid works under the hood of a lot of other Earthkit packages to make it really, really straightforward to just grab your data on a complex grid and then work with it like it's any other data. So there's a basic example here. This is using Earthkit plots and grabbing so this is some heel picks data. Hopefully the resolution's high enough that you can see that when we call the grid cells function, it's actually visualizing all of the original heel picks grid cells very nicely, so you can see all of the original grid pixels and the grid points as well as a red dot in the center of each grid cell. You can do the same with octahedral data, and you can also interpolate it onto smooth contours if you want to visualize it that way. But it's also supported, so Earthkit Regrid is also used in other packages to make it easy to process your data without worrying about what your grid is. It sort of just works. Then we have Earthkit Geo, so that provides tools for working with geospatial shapes and coordinates. So it's another simple high-level API. It provides things like accurate globe-aware computations, so things like point rotations or getting geometries for countries and regions. So in the bottom left here, this is asking for the outline of Spain, France, and Italy, and it gives you a nice shape that you can visualize with Earthkit plots or use with other tools like Earthkit transforms to do a mask or things like that. And then we have Earthkit plots as well, which makes it quick and easy to produce publication quality visualizations. Again, it's another very concise high-level API. It's built on top of Matplotlib and CartoPy, but it removes a lot of the boilerplate code you would normally need to write in order to get your visualizations. It's sort of similar to, it has features sort of similar to Xarray's plotting function, but with much more geospatial aware functionality. So things like being much more aware of projections, domains, able to add grid lines, coastlines, all of those sorts of things on top as well, but still with a very high level API. As I mentioned before, it supports complex grids out of the box. It also offers intelligent formatting based on metadata, which means you can do things like put format strings in your titles, where you say things like put the time here, put the lead time here, put the variable name here, and it will just populate all of those things from your metadata as long as your data supports common metadata standards. And it also has customizable style libraries, so you can write a bunch of styles for specific variables that might be specific to your organization or project, and then you can visualize the data using those styles very easily. So in the context of Copernicus, Earthkit also provides direct access to data from the Climate Data Store, the CDS, the Atmosphere Data Store, the ADS, and also WEkEO's HDA API as well. So inside Earthkit data, we have this function called from source. This is the function where you get data from a local file or a URL or an S3 bucket. But in the same way, you can also ask for data from Copernicus platforms like the CDS or WEkEO. But in much the same way as the workflows where you would get data from a local file, you simply ask for data from that specific source, so from WEkEO or the CDS. And what you get out of the end is the same object you would have got if you had a file local on disk or a file at URL. So then you can do things like turn it into Xarray or NumPy, or you can continue through the Earthkit ecosystem to process it with something like Earthkit transforms or Earthkit WEkEO, or visualize your data with Earthkit plots. So Earthkit is incubating. It's essentially in beta under active development by ECNWF. It's already used by ECNWF in some places in operations, but it's also being developed with very much with Copernicus in mind, also with Destination Earth in mind, and of course ECNWF core activities in mind as well. It's already available to install through Conda, pip, and directly on GitHub. And as I mentioned, it's fully open source and open to contributions. So you're very, very welcome to go and explore the code, make a pull request, raise an issue on GitHub. So we recommend pip as the easiest way to install Earthkit. So you can, given Earthkit is an ecosystem of modular tools, you can install just the parts you need if you like. So for example, you can do like a pip install Earthkit data or Earthkit plots to just get that package. Or you can grab the whole ecosystem of tools in one go with a pip install Earthkit, and that will give you the latest versions of all of the tools in the Earthkit ecosystem. So thank you very much. A few links there. So there's a link to the GitHub page for Earthkit. the website that we have as well, and also the read the docs. So feel free to go and explore. Reach out to us on GitHub if you have any issues or any contributions you'd like to make. And yeah, thank you very much.
Thank you, James, for this presentation. I think we can move on again to our next speaker, and our next speaker is actually a previous speaker, is Anna-Lena again. She will speak about Innovation Lab and some commercial offers. So Anna-Lena, welcome back again. You're
Yes,
mute.
yeah.
Yes, okay, good.
I hope you can see my screen.
Yes,
Okay, that's
everything is
good.
great.
Hello again. It's me, and I am now gonna talk a little bit, like really briefly, about WEkEO additional computational resources. So at some point, you might reach a point where your project, like your Earth observation project, is getting too big for the quota the Harmonized Data Access API or the EOCanvas offers, or it's getting too big for the computational resources of your laptop or the computational resources available in the WEkEO workspace, so in the Jupyter Hub environment. When you reach that point, what do? What has WEkEO offer for you? So we do have several offers on how you can increase your WEkEO resources. So this is a screenshot from the WEkEO website, which you can check out when you click on the scaling up data access point. So we have like the software tools, which I, for example, with the EOCanvas, I already introduced, but we also have the offer of processing infrastructure. Now, like going back to those three different scenarios, okay, your project is getting too big for the HDA or the EOCanvas quota. That is actually a problem, especially with the harmonized data access. It currently has a quota limitation of 100 requests per hour. And so if you're running into this issue, that's actually no problem. Just write an email to the WEkEO user support at support@wekeo.eu, and then we can just take care of increasing your download quota. Same we can do for the EOCanvas processing quota. So if you have like a really large time series where you just want to like extract some pixel value, or you want to extract like some really small subset, and your EOCanvas quota, which is currently around, I think, 100 processes per month. So if that is maxed out, you just write us an email with like a small description of what you want to do, what you plan to do in your project, and then we can, for a certain amount of time, increase that quota for the time of your project. So what happens if the project gets too big for the computational resources you have available on your machine, for example? So then you need additional processing resources. WEkEO has different offers for that. One is a free offer, the Innovation Lab, and we have also commercial offers, which is then organized by our infrastructure provider, Thales Alenia Space and Cloudflare. So what these two offers include is practically you get a tenant on the cloud. What does it mean? It means that you can either get through the Innovation Lab or buy through the commercial offer virtual machines. So like somewhere a server on the cloud where you can decide on how much resources you need. Do you need 8 CPUs? Do you need 100 CPUs or 128? How much gigabyte of RAM do you need? How much gigabyte of storage do you need? So all this can then be configured by yourself according to your needs. So if you are interested in the commercial offer, you can just see the price list, and then you will be in touch directly with the infrastructure provider. So in this case, Cloudflare. If you are well, if you have a project which is eligible for the Innovation Lab, then you just, there we have a form where you can apply for the Innovation Lab, and then you'll get in touch with like some of my colleagues and like colleagues across the WEkEO partners who will then take on your project. A little bit more information on the Copernicus Innovation Lab. So this is the free option to get like the services which I mentioned before. So a virtual machine with how many RAM you like, CPUs, even GPUs, so graphic processing units, if you have some machine learning projects, and object storage. So all of this you can get through the Innovation Lab. The Innovation Lab was founded, it was established to offer resources to projects, to innovative projects, which make use of the Copernicus data and Copernicus services data and Sentinel data that kind of benefit economy, society, and environment. So who is eligible to apply for a Copernicus Innovation Lab project? It's projects of Copernicus users from the Copernicus member states. So that is an important point. So if you or your university, for example, where you're doing this project with, or the company, that startup you're doing the project with, if that is like located in a Copernicus member state, then you can apply for the resources. And once your project is accepted, then you will get the computational resources for the duration of the project. That can be 3 months. It can also go up to a year, for example. That really depends on the case by case basis, depending on your project and the available resources. But yeah, you just let us know in the application process. If you scan this QR code, you will be redirected to the website. And yeah, also here, when you're at the website and when you learn more, you will be redirected to the application form. It's not a long process. It's just a couple of questions where you'll be asked on your project, like what's your plan, what data will you use, how much resources do you approximately need, do you need only CPUs and RAM, do you also need GPUs, and so on. And then we get the process started. And that's already it from the additional computational resources. So back to you, Daria.
Thank you, Annalena, for your presentation. And well, now we will have another part, which is WEkEO Development Outlook. And now Annalena already presented her part, and or you still have something to add for that, or we can go back to Mikael fully.
For the Outlook, I think Mikael can start and then I take over.
Okay.
Or I can also do the Outlook from our side already now.
Yeah, as you wish.
Okay,
you can,
then I'll just continue. I just continue sharing my screen because the next part is this is now the last series of this WEkEO Essential series. I just want to share a bit with you like what the future will look like. So what is in the pipeline, what new services, and so on. So a bit of a development outlook for WEkEO. And so I think this part is split into 2 parts. I present some of the development outlooks, which are done under on the EUMETSAT part. So within EUMETSAT, we're working on some developments, but also the other partners of WEkEO are also doing some developments. So after my part, I'll hand over to Mikael from EEA, who's going to present some exciting development outlooks from EEA, like the European Environmental Agency. But now for EUMETSAT, so what is in the pipeline for WEkEO? First of all, GPUs on the WEkEO workspace. This is really exciting, and we've been looking forward to this development for a long time. So I think it was launched last week. So from last week, Monday on, you now have the possibility to access GPUs on the WEkEO workspace. So inside the Jupyter Hub, you can now run like small machine learning models. Here is an example of the Llama model, like just a really small demonstrator, like how you can use the GPUs to describe a satellite imagery. And this is really nice. It's live already, so it's not so much of an outlook, but more of a small advertisement. So if you go on the Jupyter Hub and you have the server option selection, you just select the machine learning GPU server, and then you can try it out yourself. So that's really exciting. So go ahead and try it out. Then we are also working on Dask on the WEkEO workspace. So if you have large amounts of data and you want to parallelize your processing, you can use Dask, and we are working on a Dask gateway on the Jupyter Hub inside the WEkEO workspace, where you have additional resources, like extra resources dedicated to different Dask workers to enhance the parallel processing of your data. This is coming approximately in September 2025, so stay tuned. What is also in the pipeline is a Stack interface to the WEkEO catalog. So Stack is everywhere nowadays, and so it will also be in WEkEO soon to be more interoperable with other platforms as well. This is how it approximately look like in the future, like a small prototype we've done already, and this is coming in August 2025, so stay tuned. And finally, what we're also working on is a chatbot assistant on the Jupyter Hub. A WEkEO workspace code snippet generator. This is just a generic image on how it will look like. So you can it is planned to have a chatbot assistant here inside the Jupyter Hub, which can support you in writing notebooks using the WEkEO services. So it can help you then to create some code to access data through the HDA, to access data through the Earthkit or the EOCanvas to really get you started when you are new to those services. This is coming in the end of 2025, so also for this, stay tuned. It's really worth it to follow a bit the WEkEO webinars and so on, to be aware of the newest developments. And with this, now I really hand over. Thank you very much, and over to you, Mikael.
Great, thank you, Anna-Lena. And Mikael, I think the floor is yours now.
Thank you. I will start sharing my screen.
We can see it.
Great. Okay, I will just demonstrate a new plugin that we are working on that is helping or supporting working in QGIS with the WEkEO data, and it's using the HDA client mainly for getting data out from the WEkEO dataset. So it's a plugin that it's a beta version now, so the full functionality is not there yet, but as you can see, it's this part on the, it must be on the right side for you. Yeah, and it consists of some settings. So it has a user account, so it's the WEkEO account. So if there will of course come some information here on the login that you need to have the WEkEO account and a link to that. So if you already have a key account, you can log in here, save your credentials, and then it will be stored. And if you already have stored your credential using the client and use the default savings, options, then it already is there. So you don't have to log in again. And then you can also already here accept the terms and conditions for each of the product. And also you can set the path, default path where you want to download your data. And then you can set the limits in search for the files. And it's just a default value. So as you can see down here, it's 500 right now. And then you have a, like in WEkEO viewer, you can have this queue filter. So here I have all the queue products. And if I want to, for example, find high resolution layers, I can write HRL and tap enter or click at the update button. Then it'll figure out those HRL. And here I have 6 different products. And if we take grassland, then we have the abstract here. And we can also see the related VMS, or yeah, here is a VMS services. And you can select one and you have the information, and then you can add it directly, this single layer, to directly into QGIS. So now we have it in QGIS, and you can add more if you want layers. And then you also have this product download using the HDA client. And here we can take the same. We can start showing the query parameters, and it's generate dynamic because they are different from each product. So if we want to see the same, we can say it was a grassland change, and the resolution was 20 meters, and the year that's was it 18 to 21. And then if we want to draw a bounding box, we can do that here. If we want to take this area, it's one, go back. Then we have the coordinates, and then we can search this. And now if there is more than 500, then we will only get the first 500. But here we have 42, and then we have a total size of 50 megabytes. And now we have all the files that is available for download and the size of each file. So you can select single ones, you can select all, or clear. And if you just want to download, let's say these two, or let's say like this, then it's just selecting download. And here it's running it in its own thread when you're downloading, so you can still use QGIS. And now you can see it has downloaded the selected files, and they are stored in the directory that I set. So, and then we also have for example, in QGIS, it's easy also if you have some time series. Let's see, PP. And we can take. So if we go to the VMS, we can, for example, add a layer. Now we have time series, and I'll just do like this. And then we have our time series here. So it's very easy to access data through VMS or download data. And what is up? So then we will also hopefully add a data catalog, this bottom that is disabled here, where it's possible to get the product catalog for the selected product. So we have the description, and in the future there will hopefully also be some filtering on the layers that you can select for the VMS services. Yeah, and I guess that's pretty much what it can do right now. It will, of course, we are continuing to get all the VMS and VMTS service in, and also because that's not a part of the HTA client, so we need a way to streamline that, so we have a data set with all the VMS services. But the product download should work because we have this HTA client that is built on, and it does all automatically generate the career parameters. So yes, that's pretty much that for now. Hopefully there'll be more development in the future on it. So, but right now we are streamlining it so it works on all the existing data. Yes, I guess that is. Thank you.
Thank you, Mikael. We can now continue with our use case presentation. And then questions for Mikael and Anna-Lena, we will, and to James also, we will look at them after. So for the use case presentation, we have Stefano. Hi, Stefano.
Hi.
And well, he will present you his project, his company, SaferPlaces. So the floor is yours, Stefano. You can go.
Yeah. Okay, thanks a lot for this opportunity to WEkEO, the team. So my name is Stefano. I'm the founder of SaferPlaces. SaferPlaces is an agentic AI digital twin platform for providing flood risk data, flood risk intelligence in urban area. So this is our story. This solution has been generated thanks to EU-funded research project funded by EIT Climate Kick from 2018 to 2021. And then we receive support from European Space Agency and also from Horizon Europe with some grant to continue to develop the solution. And so far from 2023, we are in the market. So we have a platform fully operative. We have several licenses sold to municipality mainly and civil protection. So to support multiple users in dealing with flood resilience and disaster risk reduction. So when we started our journey, we had this question in our mind: are our city ready to face the next extreme event? So here you can see this sheen related to Emilia-Romagna, the region where we are based. We had 4 major flood events in 2023 and 2024 in the center of Romagna, where most of thousands of people has been displaced from their homes. So the question is, maybe there is still some road to do, something to improve, and we believe that the key is the knowledge and what we call flood risk intelligence. For us, flood risk intelligence is this capacity to generate on the fly flood risk data for historical condition, for real-time condition, but also for future climate change scenario. And the aim is to have this information for the 3 types of flood events that can occur in a city, that are pluvial, fluvial, and coastal. So the innovation that we try to fulfill with our solution is related to 3 main aspects. The first is the availability of high resolution data. So floods are very spatial distributed phenomena. So even 2 buildings in the same road are not flooded in the same way. So resolution matters. The second aspect is to simplify the capability to generate this information that now require CPU-intensive cost-time solution, and also to have a capacity to produce maps on the fly, not in a static way, but more taking consideration a climate that is changing and also changing condition in the city. So the solution is a cloud web application that is available like a software as a service solution and also through API. We have a global platform that can be activated in every city worldwide. And the resolution depends mainly on the availability of the digital terrain model. So most of the countries, we have LiDAR dataset that give us the capability to generate data 1 meter resolution, 2 meter resolution. For the rest of the world, we have the 25 meter resolution of the Copernicus DTM. And the technology is based on 3 main pillars. First is the capacity to generate the digital twin of the city. So we combine in a sandbox, in an automatic sandbox, all the layers that we need to run our models, starting from the terrain, the digital terrain model, the building footprint, the infrastructures, the climate data, and also we have a connection through Copernicus to automatically acquire a Sentinel Copernicus dataset. So once we have the digital twin ready, we have the second pillar of the technology is composed by a flood hazard and damage model that we have developed together with the research center and university, and also some processing routine that automatically retrieve flood mask from satellite dataset. Everything is combined into a cloud computing system that give us the computational power that we have generated a scalable computational power that give the capability to generate and run simulation in real time. And so the platform and the solution can be used for running multiple flood scenarios with a changing climate, but also changing the condition into the city. So for example, testing flood mitigation measures like seawalls, changing the permeability, adding storage tanks, so the user can also simulate what can a resilient city can be in terms of flood reduction. This is one of the applications that we are using together with the civil protection here in Emilia-Romagna, is the more related to the nowcasting, so the capability to run in real time simulation of the flood event related to pluvial. This is a water bomb occurring here in Rimini. So we have capability to feed in real time radar data set or weather forecast engine and transform them into a flooded area. Another application is more related to adaptation. So we are here in Rimini again. We supported the municipality of Rimini to design a big nature-based solution project that is basically composed by an artificial dune, a green park that protect the city from future coastal flood events. Thanks to the functionality of the platform, allow the user to also compute and compare different scenarios, defended and defended, and also compute a sort of cost-benefit analysis. We have also, through the platform, the capability to visualize in 3D, thanks to the Google API. And this is, for example, the scenario without the Parco del Mare, so the nature-based solution project. And this is the visualization with the flood barrier that protect the city of Rimini. Yeah, this is another application with the civil protection in Emilia-Romagna. We are in Faenza, that is one of the cities that has been affected during the recent flood event. And the technician of the civil protection used the solution to simulate and forecast possible river flood events generated by breaching of the banks of the river or overtopping the banks of the river. So this is the simulation that we have generated before in a forecasting way under the hypothesis that banks of the river collapse. And this is the extended flooded area simulated by SaferPlaces. On the right, you can see after the event, because at the end we had an event in this area. You can see the comparison that is pretty amazing in terms of replicating what has been forecasted by the model. So this is possible thanks to the LiDAR dataset that is available in this area. And thanks to our satellite-based routines, we supported also the region to assess the flood extent in 2023. And we also contribute to evaluate not only the extent, but also the depth, the flood depth, the water depth. That is an important parameter to evaluate and estimate the total damage. So Recently, we started to reasoning with the agentic AI and try to embed this technology into our solution. And we ran a project together with founded by ISA and together with Cloudflare and Trillium Technology. The project is called WEkEO. And WEkEO is an agentic AI that basically understands through an LLM ChatGPT-like interface the way to orchestrate the different API that compose the technology of SaferPlaces. So basically, the user can interact with a classical ChatGPT interface, and at the end, agentic understand which is the flow and the graph to be deployed in order to run automatically the simulation. So the experience of the user could be ask to WEkEO what you can help, what our WEkEO can help you. Imagine to be a civil protection officer, and you can ask to the agentic version of SaferPlaces, can you please activate SaferPlaces and build the digital twin of Valencia? And so the agentic AI start to build the digital twin, and then you can ask to simulate a specific scenario after the generating of the digital twin. And for example, you can ask to run a simulation of 200 millimeter during the last hour that occur in the area of Valencia. Automatically, the agentic understand which API need to activate. And then after a few seconds, you can see the visualization of the flooded area due to the specific flood event. So this is another visualization you can enrich with some information and alert to be shared with the civil protection officer. And so this is, for example, another visualization in 3D where the users ask to the agentic AI to insert a flood barrier in a specific neighbor. You can see in red. This is an area where we have located where an hospital is located, and the idea is to protect this area from the flood extent. Another application of the agentic AI could be to activate the routine related to Sentinel, the capacity to automatically process Sentinel Copernicus data and automatically retrieve the flood extent. So this could be done through a text-based or ChatGPT-like interface and automatically displayed into the plan. So that's it. Maybe I have a few minutes left. I'm happy to answer to some questions during the Q&A session, and thanks a lot for your interest.
Thank you, Stefano. Thank you very much. I'm sure we will have some questions for you. Now we will move to Q&A session, and it will consist of 2 parts, and Marine will tell you how it's gonna be.
Yeah, thank you, Daria. Well, thank you very much, Stefano, for the presentation of SaferPlaces and these insights into flood risk intelligence. And of course, thank you to all the speakers today. So as Daria said, we will now go to the Q&A session. And I see we have questions coming in. But before we start the Q&A, we just wanted to give you a reminder that replays and presentations from speakers will be available a few hours after the session. We will also send you a certificate of attendance by email, and we encourage you to complete the survey to give us your opinion on the series. There's a link available in the chat on the event platform. So we will now begin the Q&A. So first, we will take questions from those who have raised their hands on Zoom, and then we'll move on to the written questions submitted through the Q&A tab. So feel free to keep adding your questions in the next few minutes in case we don't get to them immediately with the hand raised part. And so remember, you'll have up to 3 minutes to ask your question and chat with our speakers before we move on to the next participant. Okay, so let's start with the Zoom Q&A. So I can see we have a few hands raised. So I will go to the first person who raised their hand, and this is Laili. And I just give you the permission to speak. So you just need to unmute yourself. You should see a white square on your screen, giving you the opportunity to unmute yourself. Ah, I see that you've removed your hand. So we will go to the next person, maybe. And the next person is Nidhi Gopal. And you should be able to unmute yourself now.
Yeah, hello, can you hear me?
Yes, we can hear you.
Yeah, I have one question to Stefano, sir, that can users integrate Amazon Web Services to access and manage observation data on cloud with your cloud computing techniques, which you have shown in the presentation?
Yes, we have already some data connected to SaferPlaces coming from AWS. I think so. In the activation of the service, in the generation of the digital twin, the user can select among open data set that has been already connected or embedded into SaferPlaces platform. But you can even upload or connect your own data set through API or through S3 buckets. So this is definitely possible. So in the generation of the digital twin, you are quite flexible to add your data set related to digital terrain, related to building footprint, soil type, land use, and also satellite data set.
Okay. Thank you very much for informing. And I have
Thank
one
you.
question to Anna, ma'am. Can users utilize MATLAB software to analyze maps and charts using it for data visualization in conjunction with EOCanvas tool?
Okay, thank you very much for your question. Currently, the EOCanvas Python package, like the wrapper, is only in Python, but EOCanvas in general is an API. So it's language agnostic, so you can like also execute the EOCanvas within like from the command line. If your question is like more on, okay, is MATLAB integrated as a software toolbox in EOCanvas? The answer is no, not yet. We currently only have Snap, like the ESA Sentinel application software, and the Humansat data tailor implemented as software on the EOCanvas.
Okay. Thank you for the clarification. I have one question to James, sir. Is installing the CTS toolkit and updating the license it's a one-time setup, and what are the most commonly used libraries for data analysis?
Hi there. Thank you for your question. Yes, so it is. So it's as with typical Python libraries, it's a one-time setup to do the installation. But of course, it's under active development. So when things get updated, you can always pull the latest versions with a pip install update. Yeah. Sorry, what was the second part of your question? Oh, I think you might have gone.
Hello, can you hear me?
I can hear you. Yeah. Sorry, what was the second part of your question?
Hello.
Yes, we can hear you.
Sorry, I got the first part of your question about is it a one-time installation, but I didn't catch the second half of your question.
Yeah, what are the possible libraries are you using in conjunction with Python?
So the most popular tools in Earthkit at the moment are probably Earthkit Data in particular, which is used to access all of the different kinds of data sources, so GridNet, CDF, SAR, GeoTIFF, the whole the whole shebang. And that one is built on top of NumPy, Xarray, Pandas, but also lots of things like ECCode to ECWF to handle grid data. It's a whole suite of tools under the hood, but Earthkit Data is definitely the most popular Earthkit tool at the moment, probably followed by Earthkit Plots. Those are the two most mature libraries. So yeah, I encourage you to go and play with them.
Okay, fine.
Thank you very much. Thank you very much, James. And we will now go to the next questions, which is from Timea. And Timea, you should be able to speak now.
Thank you. Hi, everyone. Thank you so much for all the presentations. It was really insightful. I have a question to Stefano about the digital twin and cities and working together with the local governments. I think it's really impressive how far we are getting with the ability to use ML and other tools to do prevention. I live in Spain right now, so when you were talking about Valencia, it hit close to home. I really like that. So my question is, seeing more and more tools popping up doing this, and you actually drove through and worked with the local governments, how far do you see the implementation is going? My question meaning the civil protection starts to understand the abilities that you're presenting, but how does it trickle down to the actual sensor level, activation level, reaction level in reality?
Thanks a lot for this question. Hard to answer. I mean, one of the key elements that I believe can improve the real use of this tool is the capacity to co-generate together with the users from with a bottom-up approach. So this what has been done during the research project. We involved since the beginning the civil protection officer, and we start co-designing with them the solution. So I think this is the secret, the main, most important element, because if the end user is involved, at the end you co-design an application that fulfill all the user requirements. And now we have seen that, so the evolution also. So we are working in agile mode, and so we start with a POC, and then they are happy, but they want more functionality. So we discuss this new functionality. Now, for example, we are working in integrating all these sensor radar data, the rain gauges, and so on. So, I mean, this is my thought.
I have a follow-up question, if you don't mind. I love what you said, involving them and working together closely with them is the way to get this in and get into their heads as a tool to work together with. Now, how global do you see the civil protection systems? How transferable is the knowledge that you're gaining from the Italian municipalities and reaction there to Spain or even across the globe?
Yeah, I mean, so technology is there. I think the capability to replicate the technology worldwide is already a reality. We have a lot of data, a lot of climate satellite. DTM is also available at high resolution, more or less at global scale. So there is not a technological barrier, but it's more maybe the willingness to of the region of civil protection to explore this innovation and start co-designing with technological purveyors a solution like this. But yeah, I see a good potential. Yeah.
Thank you, and thank you for your answer, and good luck with everything. I love this project.
Thank you. If you need more info, just contact us.
I will. Take care.
Thank you, Timea.
Thank you very much, Timea. And now we will go to Syed Rafi Ahmed. And you should now be able to speak and unmute yourself.
Want to know that we can use the Google Earth, Google Colab for the programming and all if you are on the remote, so that we can do all the things for the Python.
I'm sorry, I didn't quite understand your question. Could you repeat, please?
Can we use the Google Colab for the Python for all the for all the data? Google Colab. if you are on the remote and we have the access to the other computer, we can use online for the to do work remote, and we have the proper Wi-Fi connection or what. We can use a Google Colab, or we have to use the Python only.
I think Annalena might have an answer for you.
Yeah, so the tools introduced today, especially the EOCanvas, also the Earthkit, it's just Python libraries. So it's independent on where you want to use them. You can use them on your local machine, you can use them on Google Colab, you can use them on the WEkEO workspace, so on the WEkEO Jupyter Hub, which is actually same offer as Google Colab. For the xcube viewer, that is actually a bit more difficult because that needs like some configuration on the server side. So I've tried it myself, and it's not possible to use the xcube viewer in Google Colab. So for this, I can really recommend going to WEkEO and go on the WEkEO Jupyter Hub to have the function of the xcube viewer inside the notebook.
Okay, thank you.
Thank you very much for your question. I will now go to Belo Sajir Dakari. Sorry if I mispronounce your names. You should now be able to unmute yourself and ask your question. So Belo Sajir Zakari.
Hello.
Hi.
Hello, I'm Bello Sogil Zakari from Nigeria. My question here is that is the app only developed for those that are using computer only, or it can be both developed in the smartphone or on computer?
I'm sorry, there's an echo, and we couldn't quite understand the question. Could you please repeat it?
Okay. Are you with me?
We can hear you, but yeah.
My question is that is the app developed just to install on a computer, or it might be installed on smartphone?
Do you mean the WEkEO website?
Yeah.
I mean, it's a website, so I guess you can use it on your phone as well. But I'm not quite sure that you would be able to use all the tools and download the data as easily as on a computer.
Okay. Thank you so much.
Yeah, sure, no problem. And then we will go to the last person raising their hand, and this is Gérald Mvoumi. And you should be able to speak now.
Okay, hello. Are
Hi.
you with me? Well, I'm okay. I'm very much grateful for such an insightful session. And the thing is, my question had already been asked. It was gonna be directed to Stefano, but well, I'm so much grateful for the feedback that he actually had given. It was referring to digital twins and the stuff he was mentioning. But well, it's been answered. So I would like to appreciate for this insightful session. And on that note, I would like to know, I actually missed some previous sessions, but then I realized that I actually it was quite unfortunate. But then I would love to know if you are gonna issue certificates for attendance. I read something about certificates on the previous emails. Then I actually didn't have the privilege to attend the previous ones. But then I attended this one. It was quite an insightful session, and I really appreciate. But I want to know.
Yeah. Thank you. So yeah, you will definitely get a certificate of attendance for this one as you joined, and it will be sent to you by email today in the afternoon or tomorrow.
Okay, perfect. Thanks a lot. And to Anna and all the team, I really appreciate. Thanks a lot for this session.
Well, thank you. I'm sure everyone is happy that the content shared is helpful, and we hope that you'll be comfortable using WEkEO from
Absolutely.
now on. Thank you. Okay, well, I don't see any more. Oh, just one last person raising their hand, and then we'll go to the written part of the Q&A session. So, Davi, you should be able to speak now. Davi Emaneke Andrian. Sorry, I don't see your full name. Hello. Hello.
Can anyone hear me?
Yes, we can hear you.
Hello, everybody. Is it hello?
Yes, we can
Is
hear
it
you.
possible? Yeah, just a simple question. I didn't have I wasn't privileged to attend the first session, but the two last one. So is it possible to retake it and to get certificate, please?
I mean, you can watch the
Just
replay that is posted on the event website.
per curiosity.
Yeah.
Just simple question, just technique. It has nothing.
Yeah, so you can actually watch the replay of the first session that is available on the event website, but we wouldn't be able to issue an attendance certificate for that. We only issue them for the live sessions. But yeah, feel free to watch the replay and visit the event website, because there are links to all the useful resources that we've been sharing throughout the last three sessions. So thank you very much for all your questions. And now we will go to the ones that were asked on Slido. And so I will now give the floor to Daria.
Thank you, Marine. Yes, now we go to Slido. We have some questions already. So, well, let's get started. And the first question, is the general EUMETSAT data store accessible from Canvas or only the data tailor? Well, there's no attribution to who this question is, but I think
it
it's
goes
your
to me.
answer.
Yeah, so from the EUMETSAT data store, there are specific data collections also within WEkEO. That is the case for the Copernicus data, like the Sentinel-3 data, the Sentinel-6 data, and also selected data sets from the SAFs, like the satellite application facilities. So then you can also access some data from MSG or from the METOP satellites. So I can just invite you to go to the WEkEO data catalog and then filter for EUMETSAT as data provider, and then you see what data sets from EUMETSAT are available through the WEkEO HDA.
Okay, thank you. I hope it was it answered. Well, the next question is again for you. Is it possible to access internal functions such as a snap process function, and where is it located?
I'm not sure if I understand the question. So, like the snap process function of the API, it just sets the scene of what input is needed, what output is given, and on the back end, like which software is the request redirected to. So for the snap process, then the system knows, okay, then we'll redirect it to the snap software deployed on the cloud. if you want to like really define your workflow, that is not done through the snap process function, but that is actually done through the workflow, like this, for example, XML file you've seen for the snap process. And this is something you can really just tailor as you like it. So if you have a snap process in place where you do like some really specific atmospheric correction or like some calculation on the data itself, you can just use that process and one-to-one transfer it to the EOCanvas. And you can also use the functions which are in, for example, Snapista, if you're familiar with that Python package. Like, it's a wrapper for like building this snap graphs. So you can also use those functions within the EOCanvas to like glue together your graph and your processes. So that's like the level of freedom you have to execute the workflows and put together your workflows. I hope that answered the question.
Yeah, I hope too. Okay, then we will move on to the next question. And this question is for James. As an individual user, can I access Earthkit through a Windows machine?
Yeah, thanks, Christina, for the question. So absolutely, Earthkit is a straightforward Python package. So as long as you have Python on Windows, which I'm sure you can find guides on how to do that if you don't have it already, then you simply need to do the pip install Earthkit. So all of the documentation on the Earthkit website, on the Earthkit GitHub, should be just as applicable to Windows as it is to any other operating system.
Okay, great. Thank you. Next question, well, it's for Stefano because it mentions SaferSpace. So can one download and use SaferSpace data for use analysis in other platforms such as G? And alternatively, can raw data from Copernicus or WEkEO be used for research?
Yes, SaferPlaces. Yes, once you activate the solution for a specific area of interest, you can download the data and use or even your QGIS or even feed the Google Earth Engine. I think to say so Copernicus or WEkEO I think can be used for research for sure. So it depends on which data. I think the license I think it's open. Yeah, that's it.
Okay, thank you. Next question is to Mikael. What potential constraints might QGIS have when it comes to analyzing data and maps? I don't know if Mikael, you hear? Oh, yeah, okay, great.
Yes. So, yeah, I'm not an expert in QGIS, but there are different plugins for it. But I will not be the expert to answer the question directly about QGIS and what it can do. So sorry about that.
It's okay. Well, thank you.
But maybe some of the other ones know what QGIS can do.
Yeah, maybe if someone among our speakers, if we use QGIS more. No. Okay.
But it's a great tool.
Yeah, it is. It is true. It is a great tool. Yeah. Okay. Then for the next question, thank you, Stefano. That's a terrific product. And is it global?
Yeah, it's global. So it's already scalable at global level. So you can define, activate the area, whatever area in the globe.
Okay, great. Thank you. Well, next question is also for you. And can SaferPlaces be used for simulations in semi-arid areas of Africa using Copernicus data?
Yes, theoretically, what we need is just a soil type characterization of the area, and we have a global data set. Also, land use, we exploit the ESA global land cover, and then you just feed the platform with forcing flood data like rainfall intensity, sea level, or river discharges. So yeah, as I said before, it's global. We offer a global service. You can improve the digital twin activation if you have a better data than the global data set that we provide for free. But the answer is yes.
Okay, great. Next question is for Annalena as well. Are the results of a process executed with Innovation Lab or virtual machines service public? For example, can they be consulted by anyone?
No. So in general, when you apply for the Innovation Lab or when you pay for the virtual machines, that is your own project. So you can, like, it's only you having access to the machines. However, you would be very welcome, especially in the frame of the Innovation Lab, to share your results. So also with us, with the WEkEO team, so that we can showcase, okay, we've supported these projects. I think like a small end presentation or a final report is even necessary for Innovation Lab supported projects. But yeah, that's about it. So the things you really do on the virtual machine, these are private.
Okay, great. Next is a question for Michael again. Has the Copernicus connector plugin for QGIS already been published? I can find it on my QGIS version 3.36.
No, unfortunately not. It's still in beta, but I guess we can release a beta version before this summer, so it will be ready in the repository in late June or in middle June or something like that.
Okay, thank you.
Yeah.
Next question is, do we need to establish the HDA access first? I think it's maybe for you, Annalena, or to James.
It could also be me.
Or maybe you. Yeah, I don't know to who.
I guess everyone is using HDA. So.
Yeah, exactly.
We can, if I can start, then the connection, when you install the plugin, then it will also do a installation of the HDA client. So if everything works well, then you shouldn't worry about that. Then it will automatically be installed. It will do a pip install in the QGIS environment.
Yeah, maybe from the EOCanvas perspective, it's the same. So the HDA is a dependency, so it will also install when you install the EOCanvas, but then you just log in with your usual WEkEO account details, and then everything related to the HDA and how the data is downloaded is happening under the hood.
Okay, maybe James, you have your perspective.
Sure. Yeah. No. From the Earthkit perspective, I mean, the WEkEO access is just one of many sources in Earthkit, but of course, you do need to have your HDA access set up first if you want to use the HDA adapter. It does also provide a prompt if you run it in a Jupyter notebook, it will provide you with a prompt to log in as well. But yeah, you do need to establish the HDA access first.
Okay, great. Okay, so I think we all had perspectives on that. And last question is, can use a point file from a CSV in selecting my area of interest to visualize in WEkEO? I guess it's a question to, basically everyone who uses WEkEO, but James, maybe? Yeah, okay.
I can give you just an Earthkit perspective on that. So Earthkit does provide tools for if you have point data in any format. So it could be CSV, could be GeoJSON, could be whatever you have, could be an NumPy array. You can very easily select an area of interest either as a domain or as a point from some data that you already have. So you could, for example, use the HDA source from WEkEO, and then you could apply some of the subsetting tools in Earthkit to extract your point from that data. And then you absolutely can visualize that as well using Earthkit plots, but that's the very Earthkit specific way of doing that. Yeah.
Okay, thank you, James. Annalena, you have
Yeah,
something
I'd
to
say from the EOCanvas perspective, you can use the CSV file. You can read it in and then extract your AOI from it to then update the processing graph so that you have like your processing for this specific area of interest. What I don't know if that is possible to visualize in the WEkEO viewer, like in the viewing component, because I think it's not yet supported to upload your own CSV for visualization, but I don't know if somebody else has more information on that.
Well, I think, I don't know if someone else wants to say something, but I think, yeah, during the previous webinars of this series, this question been already there, and I think that, yeah, our user support team from WEkEO said that no, for now it is not supported, so we need to draw area yourself on the website. So that was the last question. I mark it as answered, and well, thank you very much, our speakers, for participating in this Q&A session, for giving your perspectives, sharing your opinions and your knowledge, of course. Thank you to participants for your questions. And now what we want to let you know, just really quickly again, about replays and polls. So on the website of event, you can find two tabs. So first one is polls. So that's basically a Q&A tab to answer some questions regarding this webinar in particular, and in the series as well. So if you have some time, please do go there and leave your opinion, your experience with this webinar, so we know better what suits you and for future events. And another tab is replays, which will have all the replays, all the presentations of our speakers today. And there you also can find the certificate of attendance. So I think Marine wants to add something.
Yeah, thank you, Daria. Well, I just wanted to say once again, thank you to our speakers, and also thank you for joining today's session and the WEkEO Essential series. We really hope that you're now feeling confident and ready to explore and make the most of the Copernicus WEkEO platform. Once again, don't hesitate to watch the replays and have a look at all the links that we've been sharing, because they're very useful. You can also go to the WEkEO YouTube channel to see the replays and other videos and replays from other events. And just one thing we wanted to add is that our next WEkEO training will take place on the 10th and 12th of June, and it will focus on climate change. So it will cover topics such as greenhouse gas emissions, extreme weather, and the impacts of climate change in urban areas. You can register to the event using the link that we're adding to the chat now, or by visiting the event section of the WEkEO website. You should now know where it is if you've joined and watched the sessions from this series. So if you're interested in live demonstrations using real data, we really encourage you to join the next session. And so, yeah, I guess this concludes the WEkEO Essential series. So once again, thank you for joining, and we hope to see you at the next event. Thank you. Bye, everyone.
Thank you.
Thank you. Bye-bye.
Bye.
Bye.
Goodbye.